Oh, I just came home from vacation, and it was a really nerdy vacation. I visited LKAB, the company that produces these small nodules. This is the iron ore from the northern part of Sweden, and I learned that this ore goes into the blast furnaces where they produce pig iron, and normally pig iron is something blocky, but look at this. This is pig iron granules, shots. Have you ever seen any of that before? This is the new method. 360 ton per hour. Do you believe that it is possible to produce 360 ton per hour of these granules? You better watch this episode because Kristina Beskow from UHT, these guys, and there, they have built machines and they have technology that can transform the way the intermediate steps in the heavy iron or ferroalloy industry is changed. And in this episode, I claim that I am the master of recognizing Gran shots. Please let me know if you agree. Hi, Kristina.
Hi, Peter.
Welcome to the podcast, Everyday Metallurgy.
Thank you very much. Glad to be able to participate.
Yeah, Kristina, we met many years ago when I was working partly at Uddeholm in the mid of Sweden. You were also there, and at that time you were developing I think it was a new technology that was on the run, making granules out of hyalloid melts. I saw it. I never understood it. But now doing a podcast now 20 years later, I finally have a chance to learn what is it about, because we're going to talk about the production of granules in the steel industry.
Yes, correct.
Yeah. Will you give me a short introduction to yourself and to the company you are working for?
Absolutely. And yes, first to say it's hard to understand that 20 years passed since we met and worked together a bit in Hagfors, but time flies.
I look 20 years older. You do absolutely not.
Oh, thank you. I think we both look similar. But okay, yes. So short introduction to myself. My name is Kristina Beskow. I have a background in metallurgy. I studied material science at the Royal Institute of Technology in Stockholm, focusing in process metallurgy. And after my master's, I continued to a PhD within the field of non-metallic inclusions and their chemical evolution during ladle treatment of tool steels, working together with Uddeholm in that work.
Yeah.
Yes. So after my studies, I joined UHT, which was at that time known as Uddeholm Technology and part of Uddeholm. So I've been working here for the past 20 years within the different fields of metallurgy that we the different technologies that we supply. So I'm currently managing the group called Process and Control, which is a team of metallurgists and a team of system engineers, and we are responsible for the metallurgical design of our processes and also the development of our level 2 process control system UHT. So by that I should also introduce UHT a little more. So UHT is a Swedish engineering company. We have our roots in the Uddeholm and were formerly known as Uddeholm Technology, but since 2007 We are a privately owned company, UHT, abbreviation for Uvån Hagfors Technology. Yeah. And we are a technology supplier for the stainless or for the steel and ferroalloy industry worldwide. So we supply metallurgical processes and technologies within 3 technology areas. The first one is the Gran-shot metal granulation process, which we will be talking about today.
Yes.
Then we also work with supply technology for AOD and CLU converters for refining of stainless steel and ferroalloys. And the third area is the UHT process control system, which is a real-time dynamic process control for metallurgical processes developed for converters, but has now been expanded to a platform for real-time control of metallurgical processes from electric arc furnace up until casting. So,
but still only in steel business.
Steel and ferroalloys.
Okay. Yeah.
So many interesting fields concerning different types of metallurgy that I've been working with in the past 20 years.
Yeah. Kristina, let's jump to it.
Yes.
I want to know about these granulates or Gran-shots, as you call them. What is it?
Well, so the Gran-shot and the granulates are rapidly solidified metals that are cooled in water. Yes, so a granulate is a metal that has been solidified in the Gran-shot process via water cooling. And it is an alternative production method in relation to traditional methods such as bed casting in layers and crushing and solidification. Sorry. And the benefits with the Gran-shot method is that it's very rapid process, resulting in a granule with a size and shape that is suitable for handling in most metallurgical processes. And it's today widely used for various types of metals throughout the world in many different installations. So starting as a process for handling excess pig iron within Uddeholm, it has spread to ferroalloys, to recycled materials, to non-ferrous materials.
Okay. Yeah, I know pig iron from blocks this size, and ferroalloy elements is typically crushed into stones size of a hand or maybe a bit smaller. What size are we talking here when we go to granulates?
So a typical size fraction would be somewhere between 3 to 50 millimeters. Majority somewhere between 5 to 30, I would say. The benefit with this solidification method, if you compare to more traditional methods, is of course that you can avoid these crushing and screening stages, which you have a longer solidification time and you have a lot of after steps in generating this final product. And if you have a very hard metal, it can of course be difficult to crush it. And if you have a brittle metal, you will generate a lot of fines.
Dust.
And dust, exactly. So that has sort of been the driver for the development and the introduction of granulates as an alternative product.
Can you share how they look? Because now I'm really curious.
Absolutely. And I actually prepared a little quiz for you here with some different types of metals. So I will show you what they can look like and maybe you can try to guess what it is.
Okay.
Okay.
Yeah.
So then I will see if I can show you. Let me see if it's possible to show them to the camera here. Is that, no, maybe I should do like this. It's very difficult to see, perhaps.
Yeah, it's a bit yellowish.
I think, is this better?
Yeah. It's shiny. Could be something containing silicium. So
Only perhaps maybe
ferrosilicon.
I think it contains maybe a little silicon, but this is going back to the roots of the process. So what I'm actually showing you now, I do like this. Perhaps you can see them.
So it's the pig iron.
It's the pig iron, yes. But they maybe get a bit more shiny here on the screen.
Yeah. Mm-hmm. I've never seen pig iron like that.
No. So we can go to material number 2 then.
Oh, how many do you have?
I have 4. So
yeah. So I'm 0 out of 1.
Is this? Can you see when I do like this?
Yeah.
Maybe they look.
It's more gray.
It's more gray and a little bit more round in shape.
Yeah. That could be something with manganese, ferromanganese.
It's a ferroalloy, so yes, this is actually the ferrosilicon, like you were.
I thought the ferrosilicon would be more shiny, like glassy on the surface.
So of course they can vary a little bit depending on the chemistry, but this is a quite typical ferrosilicon with 75% silicon, like used in the steel industry.
Yeah.
So let's go
0 out of 2.
I think we go to the next one, which is maybe a little bit. This is a non-ferrous metal, we can say.
It looks very shiny. Is it copper?
Yes, correct.
Pure copper?
Pure copper, almost pure copper. And as you can see from this shape, it looks quite different from.
Why is it so fragile?
Yeah, it's so this is produced by a different granulation method to the previous ones. With the goal was actually to make them with a larger surface area. So it was wished to have them flaky like this, in order to I will maybe mention it a bit later as well. But this is for copper foil production for electrical vehicle batteries. So this is an intermediate step in the production where you solidify them from the furnace, and then they're going further to leaching and copper foil production.
Yeah. So it's really pure, 99.99% pure.
Yeah. So the last material that I had prepared.
Yeah.
It's similar to the previous ones, perhaps.
It's also a ferroalloying element. I would say ferrovanadium. It looks a bit shiny, but the ferrovanadium I've seen has only been crushed. So
yeah. Now this is also a little bit greenish in color, if I can.
Then it's chromium.
Yes, correct. So this is a ferrochromium, and in this case, a high carbon ferrochromium.
Yeah, 8% carbon.
Yes, and around 70% chromium. So
from Finland.
Not this one, but from Europe.
Yeah.
But they can vary a bit in shape and appearance depending on its composition. So they can go from quite green until this more metal, silvery color.
Yeah.
So good. 2 out of 2. 2 out of 4.
Yeah, that's better than I hoped for. Thank you.
Thank you.
Yeah. So let's jump back. Why should we use these granules? What is the purpose of them, or the advantages compared to other elements or other ways of doing it? You said the size. Is it an advantage to have them smaller compared to the hand size?
The size fraction of the granules have shown to be very suitable for handling in metallurgical processes. I will just share my screen. So in this image, you can see some of the different applications where granulated metals and the Gran method is used today. You can also see now a little bit better the different types of, some examples of different types of granules, as you were guessing at in the quiz.
Yes, I recognize them.
So as we talked about the size distribution, so this the size distribution in combination with the rapid solidification gives you a product that is ready to use. It takes about 30 seconds for the liquid metal to solidify into the granule. And then with some dewatering and handling, so it's a very rapid process.
Yeah. What is typical time if you go hand size? Will it take several minutes to dissolve that in the melt?
Comparing to the, of course, since the size is a little bit smaller here, the dissolution time will be faster when you have granules instead of crushed materials. And they have also been proven to be able to easily handle in most of the different types of material handling systems that occur today in the metallurgical industry. So that combination with the rapid process, you get a fast quenching, so you have almost identical composition to the liquid metal in comparison to casting solidification in layers where you may have gradients in the material. You get a product with high bulk density that is easy to transport and that perform well when used in the metallurgical processes, and the process as such also have a high yield.
Yeah, I remember when I was melting myself, we had to shovel the ferroalloying elements, and we had this chromium that was crushed, the ferrochromium, and some of the lumps, they were so difficult to catch with a shovel. So you were sweating, not because you were melting, but because you were shoveling. This looks a lot easier.
Yes, and of course, I mean, you can use it. You see some examples here. So it's easily handled on conveyor belts. You can, for ferroalloys producers, it's of course their end product. So then it can be packed in big bags or drums, and it can also be handled by magnets or front end loaders if you have magnetic material and so on. So I would say those benefits together with the process, the Gran process that is possible to produce at high capacities gives good benefits.
And who are customers for such a product? Is it a steel shop, or is it also foundries? Where do you sell this?
Yes, so we can just have a look at this again. So we of course provide the technology, so we do not produce granules ourselves within UHT, but our customers are many of them are integrated steelworks, where the Gran process have become an efficient way to handle excess pig iron from the blast furnace at very high capacities. We also work a lot. We have many customers in the ferroalloy industry. For ferronickel, it's become a standard, more or less, to use to have a granulated ferronickel, and it's also common for ferrochrome, ferrosilicon. We have also been working towards developing the granulation for ferromanganese alloys.
Okay. So my guess on ferromanganese was not a moonshot.
No, so that could have been.
Yeah.
And also customers are non-ferrous and also the recycling industry. And we see, of course, a lot of new emerging interest with all the things happening in the industry right now with green initiatives and recycling and recovering of metals.
Yeah. The recycling, it says e-scrap. Is that electronic scrap?
Correct. Yes. So that's granulated copper base material recovered from e-scrap, and it's then used as an intermediate solidification step for further processing. So we have customers that use the Gran-shot methods for an intermediate handling of material, and some that have it as their end product.
Okay. Yeah, that's a new one because I've only seen this e-scrap when people talk about gold or neodymium or rare earth materials, not in bulk as this is.
No, and we have also granulated other types of metal, like more unusual, like silver and mattes. But I would say ferroalloy and the iron and steel industry is the most dominating.
Yeah.
So in this slide you can see some current and recent Gran-shot projects and how they are distributed globally over the world. So wherever there is a mine or a producer, we have our customers.
Okay, so it's mostly situated close to the mine.
Or at the producer, but for ferroalloys they could be connected close to the mine, and otherwise it's the steel plants. So both occur.
Yeah. And India is the high runner here. That was a surprise for me. Is there a reason for that?
Yes, India has been the biggest market for us in the last few years, and that is for integrated steel plants. They have large expansions going on there and a lot of investments. There are new plants coming up, so they have all selected the Gran-shot method to handle excess pig iron, both during the startup of the plants and also to handle it throughout production in case there are shutdowns in the steel plant.
Okay. Yeah, so it's a way of handling the low volume you have in startup, or if you have excess volumes during production, because you cannot shut down the blast furnace.
Correct. So that's exactly. So this shows a little bit more about that. So as a buffer between and creating a link between the blast furnace and the steel plant to be able to keep the blast furnace at high capacity at all times, and being able to handle very high capacities up to 360 ton per hour for the biggest Gran-shot plants. So some of them are intended to granulate several thousand tons per day for period of 2 weeks, for instance, or longer. So
wow, 360 ton per hour. That's more than most steel plants can handle in electrical arc furnaces.
Yes, so many of these plants have been designed to granulate directly from the torpedo ladle cars from the blast furnace. So you see here in the image,
yes,
the screen. And of course, the normal flow is to go via the steel plant, but in case of excess or shutdown, you go to the Gran-shot unit and you create your granulated pig iron that you can either use internally or also sell as a commodity on the open market.
Yeah. And how does this work to make these grand shots? I have a lot of questions on. There must be a lot of energy you have to remove when you have such a production rate, and you do that in water. How does it look?
Yes, so I will just explain a little bit about the principle. Each plant is designed based on the customer requirements and the capacity. And the principle of the grand shot metal granulation process is to distribute the metal over a large surface area of water. And then to control, as you say, the heat amount in the metal with balancing it with cooling water. That is then designed specifically for the type of metal and the granulation capacity. And then to take the solidified metals and continuously discharge it from the grand shot reactor in order to avoid any heat buildup and to make sure that we have a safe process.
Yeah, that's it's a lot of material you have to handle. I could imagine both the amount of water you have to circulate and cool and secure you have the right temperature, and also how you get the material out of the, is it called a container?
We call it the grand shot reactor.
Yeah.
So I can show you a little bit more about the key equipment and what it looks like. So we have a tundish like other types of casting. So we have the tundish to control the metal flow into the granulator by the tundish nozzle size and the metal ferrostatic head. In this case, you see this setup with we call it a spray head, but it's a ceramic disc which works as a target for the metal stream, where it hits and splits up the metal into droplets that fall into the grand shot reactor, which is a large water tank. We have water distribution nozzles placed on different positions around the tank, where cold water is continuously, sorry, now I lost the word. Where cold water is continuously entered into the grand shot reactor to balance the heat content of the ingoing metal. So we have the droplets that will start to solidify and fall down, and we have the countercurrent cooling water flow. And this warm water will exit from the top of the reactor via an overflow.
There's an overflow.
Yes, so it overflows and is taken to a hot well basin. You can just see a small part of that here, and then it's continuously circulated via cooling and returned back to the grand shot reactor. So either by cooling towers or heat exchangers. So it's a continuously closed loop cooling. The granulated material is collected in the bottom, and it is continuously discharged via an ejector air-water boost pump through specially designed discharge pipes.
So it's blown out.
Yes, so it's water and high pressurized air mixture that shoots the granules up to a dewatering unit consisting of an inlet box which have the function to slow down the material and distribute them onto a dewatering screen that we can see here, which is a vibrating screen where you have a screen deck with slotted openings, so the water will pass through and the very, very fine fraction, and the granules will exit to a conveyor belt to the stockpile. In some cases, some materials you have also a dryer unit placed after the dewatering unit.
What is the temperature when they come out there?
So the water temperature in the grand shot reactor is controlled at all times. So we have temperature sensors and also flow control of all at different positions and of all ingoing and outgoing water. So the temperature is never allowed to exceed above 65 degrees Celsius. So the products are similar in temperature to the water when it exits the Gran reactor.
And how big is it? Is it like a swimming pool in size, or is it like a Olympic swim lane?
In between. So since each plant is designed based on the capacity, the size of the reactor is varying. So the smallest reactors contain perhaps 12-15 cubic meter waters, while the larger one we are up to 120 or more. So it's quite large equipment, but still it's quite a compact footprint for the capacity that you can handle.
Yeah, 360 tons per hour. That's a lot.
Yes. The smallest units handle perhaps 250 kilo per minute, up to then the maximum that is 6,000 kilos per minute. And some granulate only small batches of a few tons, while others then are used for continuous granulation of 360 tons per hour for longer sequences.
Yeah. Does it run continuously? Are you able to switch the torpedoes and still have the pig iron in the tonnage and make it run continuously?
For the larger plants, the setup is used or the setup is made so that it can be run continuously for longer sequences. Of course, it depends on the exchange time between torpedoes. You need to do it within a certain amount of time to be able to keep the pig iron liquid in the tonnage. So similar to continuous casting. But absolutely, and there are different setups for. Of course, you need to replace the tonnage from time to time, as for all types of casting. So there are setups to accommodate this in a fast way.
Yeah, and the spray head, is that worn out?
The spray head is a consumable, so you need to replace it from time to time.
Yeah, I could imagine.
Okay, so what you will see now is a video recording from the Granshot plant at Tata Steel Kalinganagar in India. It was one of the first high capacity plants, and it was commissioned in 2016. And with the aim to granulate metal directly from the torpedo ladle car at high capacities.
Yeah.
So you can now see the torpedo
coming out of it.
The Granshot unit and being positioned towards a runner. So here we have a runner as an intermediate vessel between the torpedo and the tonnage.
Okay, like that, yeah.
Yeah.
So you're pouring now into the runner. Is like a pre-tonnage?
Exactly. And the tonnage is placed over the reactor. So the tonnage we have here. So as soon as we have obtained a metal pool in the runner, we have quite stable conditions. So here you can see the actual pouring to the runner, tonnage, and then we have the granulation going on in the left-hand side.
Yeah.
So you see the metal stream exiting from the tonnage onto the target that is centered beneath the tonnage nozzle, and we see the metal split up. We call it a metal umbrella. The granulated material exits just outside the plant via conveyor and is collected. So this is an intermediate stockpile, and it's collected by front loaders to the stockpile.
Yeah.
So the metal comes at 14 to 1500 degrees Celsius, depending on the chemistry.
Yeah. The disc where you hit is a lot bigger than I thought. What is the diameter of it?
It can vary a little bit, but it's around 30 centimeters.
Okay.
Roughly. So And now you can see we are at the end here. So the torpedo has been tilted up, and now the runner is tilted, so we can pour the last metal from the runner into the tundish.
Yeah.
So that was a little bit of a demonstration of how it can look when you granulate pig iron.
Yeah. Kristina, today people are talking a lot about the green steel transition, and every steel shop in the world has some activities to reduce carbon emission or to make things greener. Does Granulate contribute to making the green transition greener?
Yes, so there is a lot of development going on, and of course, as you see, a big market for us right now is pig iron granulation, but we also see now an increased interest in all the net zero and green initiatives that is being started up in the world or investigated, developed in the world, that there is a need for having a solid, to transport the solid material from the production site to the end user. And there the the granulated material have found a niche and an increased interest from these ongoing projects. So I thought I will just give some examples.
Yes, please do that.
So yes, we have seen, as I said, a new market for new applications with the ongoing transitions that is happening in our world right now. So I want to highlight some examples. What you see here is a case study. It's named High Force Smelt. This is an initiative by voestalpine Primetals Technologies, Rio Tinto, and K1 Met, where they together are working on a direct reduction process and smelting, where they would use the Gran-shot method to solidify the end iron product.
Yeah, I've heard of the project before, but I did not know that you were a part of that. So that's nice to see.
Yes, so in this case, the granulated material will be sort of a direct solid link between the iron making and the steel production, and also making it possible to disconnect the production site and the plant using the product.
Yeah. I have seen that some of the direct reduced producers, they want to make inline hot transfer, but that is so difficult. It has never been done before, and those who have tried it are struggling. So this is an alternative in the hot transfer to bring the iron into granules as intermediate in coal, and then you can transport it, you can stock it up without having problems. So I fully understand why this is an advantage.
Yes, and if you compare it to transporting the DRI, which could be then an option, then the Gran-shot, it's an easier handling, and you remove the problems that you have with handling and transportation of DRI, which is reactive material and requires
because it has such a big surface area. Yeah.
So this is another project that we are currently involved in. It's a similar setup, but this is in Australia, also for direct reduced iron using hydrogen to be produced by solar power. And this plant is then intended to be close to the mine, and then to solidify the product at this site for shipping it to end customers in other continents.
Okay, so it's delocalized pre-production of Gran-shots.
Exactly. And then the last example is something we talked about a bit earlier in the talk. So this is the copper granulation, which is a new area for us that we have seen an increased since we have the increase in electrical cars and the production of more EV batteries. You need more copper. So the granulated copper has been found to be a good intermediate product in this processing chain.
Yeah.
So we actually worked a lot with we have a pilot plant in Hagfors where we can do Gran shops trials, both for our own R&D work and also for customers. So that we use often to develop and investigate how material can granulate and how you can change the shape and size of them. So here we did a lot of internal tests to actually produce material that the customer could use for tests beforehand, and then they wanted to proceed with a full-scale plant.
Yeah. And it is dissolved into the bath, and then it's made in copper foil in situ, electrolyzing it.
Yes, and I'm not the expert on that part of the production, but the granules with this flakier shape, you have a good properties with the surface area and porosity when you mix them in the bath.
Yeah, I could imagine it's a lot easier to dissolve it due to the surface area.
Yeah, exactly.
Yeah.
So there is definitely a future and new areas of increased interest for granulated metals as a green link between new technologies and customers.
Yeah. Kristina, thank you very much for sharing. I've learned a lot, but I am sure that there are some of the followers who would like to learn even more, because it was a bit condensed. So what can I learn more if I'm curious?
Yes, no, exactly. We have talked about a lot of things today, and there's a lot more that you can discover. So you can sometimes find us at conferences where we participate, both in the steel conferences and ferroalloys. We have published a number of papers in the past, which you can easiest find on our webpage, uht.com. And if you have any other questions, you can always also contact us via web form for more detailed questions.
Wonderful. Thank you very much. I really enjoyed it, and I also hope that the audience has learned something new today. For me, the granules world has opened up. I had a snip of it 20 years ago, but this was a lot better. So thank you very much for sharing.
Thank you very much, Peter, for having me to attend, and I had enjoyed our conversation today.
Thank you.
Thank you.